Okay, today we're talking about, we're going to cover chapter four, four, five, and six. The first thing we're going to talk about is ethics in social science research. Um, Last time we talked about that one piece of research by Garth that showed some fairly negative results looking at different native groups around the United States, especially in the Southwest. Probably unethical. There was a lot of ethical questions. Of course, the research was done in the 1920s, and if you look at the statistics from a lot of the areas, some tribes were growing up with English as their primary language, and others were growing up were, were growing up with whatever their native language was. The Navajo Reservation, of course, was one of those areas that where their native language was very strong. I was just reading a book that was written in 1920, and it was talking about individuals coming onto the reservation and needing an interpreter because there were so many people who couldn't speak English. And this was a book written in the 1920s by a Navajo gentleman, Lafarge. You probably have heard of it. The book is called, wait a minute, I've got it right here. The book, I can't remember what the book is called. I'm reading it right now, so it's really kind of fascinating. It's a love story. Oh, I can't think of the name. Okay, anyway. Um, so we're looking at ethics, and that was probably a fairly unethical thing for them to do to compare. What was he comparing? He was comparing what he referred to as mixed breeds, people that lived in Oklahoma and people in the Southwest, individuals in the Southwest. Of course, they were looking at individuals at different boarding schools. So why do we need ethics in research? Ethical issues may arise from a variety of factors. There may be research problems. There may be a problem in the research. Um, there has been a question of genetic engineering and determinants of intelligence. How in the world does this happen? Can we compare this person and say something about the intelligence of the whole group? There has been a question about stealing DNA from select individuals who do not give them the right to steal their DNA, and that's the federal government that's doing that kind of stuff. Setting in which setting in which the research takes place. Of course, the boarding schools are fairly negative places for most of the individuals involved. Can we do research in hospitals and prisons and public schools? The interesting thing is that normally a researcher will do the research in the cheapest and easiest place he possibly can. So there's a lot of research that's being done in college classrooms where professors are giving individuals college credit for doing research. Prisons. At this point, we do not have the right to. We can't just go in willy nilly and do research on prisoners. But these are easy populations to get a hold of, and you can get a hold of a lot of individuals. Um, if we go onto a college campus, say Arizona State, is that representative of the entire United States? And the answer, of course, is obviously no. It's just people, primarily people from Arizona, but it's also young people from Arizona. So we can't really talk about how older individuals. We can't do any research dealing with older individuals in that situation. Procedures required by the research design, participant exposure to conditions that may have negative effects on the select individuals, and we're going to talk about a couple of cases where that was there was some fairly unethical research being conducted. Method of data collection. Are they looking at what they're telling you they're looking at? I have my students. If you're taking the social psychology class, I have my students go onto a website, social psychology website, where they they do research, or they participate in research that is being sponsored by the website. And a lot of times, you look at the title of the research, and then you get into it, and it doesn't have anything to do with what they said it had to do with. As curious as that is, and the question is that ethical? And the answer is, well, in some cases, as long as it does no harm to the individuals, then yeah, I guess it's okay, but it's questionable. Kinds of people serving as subjects. We You can't do research on children unless it's approved. Uh, the poor, of course, paying them to do research, they'll say anything that you want them to say. So a lot of times that would be considered unethical. Type of data collected. Are we collecting personal information? Is that ethical to do that? And now we're going to talk about one of the most egregious pieces of research done in the United States. Of course, this has a lot to do with the Black Lives Matter movement that's taking hold of the United States right now. A lot of these things have been done to African Americans, and well, and unless you understand the history of what was going on, you don't understand that African Americans were not allowed to vote. They weren't allowed to own land. This is in the South, and this went on into the 20th century, and so they were being treated as not just second class citizens, but they were being treated as third and fourth class citizens. They were, despite the fact that slavery had been outlawed, the treatment was just abysmally bad. In 1935, this is the Tuskegee syphilis study. In 1935, a group of researchers from the United States Department of Health, this is the federal government, piloted a study to observe untreated syphilis. They recruited participants from the rural South who were primarily uneducated, and most of them were black. The study lasted until 1972, though penicillin was invented to treat the disease in 1945. So they didn't treat these individuals. Because in the beginning, they had nothing to treat them with. Well, actually, they did. They could treat them with sulfa drugs, which didn't work very well. But then they invented penicillin in 1945, so they were able to cure syphilis. But instead of treating them, they just let them go. During the 40 years, participants were neither informed about or nor offered penicillin. An investigatory panel determined that the Department of Health, Education, and Welfare had failed to acquire informed consent from the participants and never offered the participants penicillin. So it was a fairly unethical situation. And there you go, a picture of the individual drawing blood from someone who has contracted syphilis, and that they're not going to treat, just to see what happens to that individual. Obedience to authority study. This is the famous Stanley Milgram experiment that he conducted at Yale University. They wanted to see how long people would obey orders. So they set up a sham research, and then they treated the research had to do with acting as if they were doing educational research. And so the idea was that they were supposed to to not electrocute, that didn't sound right. They were supposed to shock an individual if they got something wrong. And the idea was that if you punish somebody like that for not getting an answer right, the next time they'll get it right. They'll do whatever they can to get it right. It was really kind of a strange piece of research, but the idea was that they were shocking this individual. Well, they weren't really shocking the individual, but the individual giving the person the shock didn't know that. So the question was, how long will they how long will they shock the individual, knowing that they're damaging or injuring the other individual. And the board that they were using, they would shock them with a certain voltage, and then they would increase it every time. So potentially they were really doing a lot of damage to this individual. And the question was, how long will they obey orders? Some of the participants were allowed to suffer stress, of course. Of course, they were allowed to suffer stress because they were shocking people, which led to some individuals suffered from panic attacks. Some broke down. Some even had seizures. The study produced no outcome that benefited the participants. Certainly, they were actually insulted and embarrassed that they were participating in this, that they were willing to shock somebody. The experiment could possibly undermine the participants' trust in authority, of course, and that was the Milgram experiment. The Milgram experiment was put together to try to determine why the German people followed the Nazi regime when they knew that they were damaging people, they were hurting people, and the answer was people follow authority. If somebody in authority tells us to do something, we do it, and that's just the way it works. And this is a picture from the Milgram experiment. The Milgram experiment was done in the 1960s. And this is an individual. The individual on the left is actually holding the man's hand down to a metal plate so that he can shock him. And as you can see, the individual is suffering. He's a Confederate. He wasn't actually shocking anybody. Research that employs some degree of deception as part of an experiment has become commonplace because it offers methodological and practical advantages. Researchers sometimes collect data without the knowledge of the observed individuals, and some investigators are not always scrupulous about guarding confidentiality of survey data. And of course, this is quite unethical. Social scientists face the conflict between two rights. And this is the basic question. This is the one that is being argued on a continual basis. So researchers feel that they are helping mankind, and therefore they should be allowed to do whatever they need to do to discover all these principles of humanity. But the other question is, does the individual have rights? The right of the individual research participants to self-determination, privacy, and dignity. So should the researcher be allowed to do things that will encroach on the individual's individual rights? This conflict is the essence of the ethical dilemma of the social science research. And of course, this is a question that you will have to answer. So, in essence, if you are on one side of the argument, you say, well, they shouldn't be allowed to do this. On the other side, we're trying to help. Researchers are trying to help people. This is a really kind of an interesting argument. I am not a researcher, and I can see both sides of the argument. But if I were not a researcher, or if I were a researcher, then and potentially I would feel that you should be able to do whatever you want to further the knowledge of humanity. And this is a huge argument. You're taking the class from me, and so this is my point of view. But if you're taking this class from someone who was a researcher, then this would not be very much of an argument as far as they were concerned. Research involving human participants should be performed with the informed consent of the participants. In other words, they need to know what the experiment is about, and they need to know what their rights are. According to the United States Department of Health and Human Services, researchers are required to obtain signed consent forms from study participants who are to be placed at risk. The guidelines: the participants should know that they're involved is voluntary, that their involvement is voluntary at all times. In other words, they can stop anytime they want. They should receive a thorough explanation of the benefits, rights, risks, and dangers involved in their participation in the research project beforehand. Reasons for informed consent derives from both cultural values and legal considerations. It is rooted in the high value we attach to freedom and self-determination. Regulation and laws have been enacted in order to guarantee that individual freedom has been preserved. Informed consent shifts part of the responsibility to the participants for any negative effects they may experience in the course of the study and simultaneously reduces the legal liability of the researcher. As long as the researcher has told the individual what is going to happen, the participant has the right to remove themselves from the research at any point during the research process. Clarifying the intent of informed consent, it involves four elements: competence, voluntarism, full information, and comprehension. Competence refers to the understanding that any decision made by a responsible, mature individual who has been given the relevant information will be the correct decision. And of course, this is one of the problems with doing research with children. Do they really have that information? Do they really have that knowledge? And of course, if you're going to do research on children, which isn't done very, it's not easy to get approval to do research on children. But if you do get approval to do that, then the parents have to approve the research. So the question is competence. And somebody in prison, do they have the right to say yay or nay? Are they competent enough? Somebody who has a mental illness, and this is one of the reasons why psychology has struggled so much. We can't do research looking at an individual who has a mental illness, and so it really changes things. Voluntarism, social scientist who complies with the principle of informed consent ensures the freedom of participants to choose whether or not to take part in a research project and guarantees that exposure to known risks is undertaken voluntarily. And voluntarism has to do with what the Nazis were doing during World War II, the fascists during World War II. After the war, we discovered that they were doing experiments on prisoners and on individuals that they deemed non-human. They were doing research on Jewish captives who they were executing. They killed as many as they possibly could. So they came up with the Nuremberg Code, and the reason it's the Nuremberg Code is because the trials of the Nazis after World War II they were done at Nuremberg, which is a city in southern Germany. And so they came up with this code, and of course we have signed on to the code. Everybody has signed onto the code. It's really kind of curious because the current president has threatened to remove the United States from this Nuremberg Code. I don't know why. He's kind of he does odd things from time to time. Anyway, the Nuremberg Code delineates the researcher's responsibility to explain the research prior to voluntary consent. This means that the person involved should have the legal capacity to give consent, and of course, that's a prisoner would not have that legal authority, and neither would a child, and neither would somebody with a mental illness. And this is one of the almost all the countries in the world have signed off on the Nuremberg Code, so we can be assured that this type of research isn't being done. But we can look at different aspects. At one point, the federal government sprayed LSD as an aerosol in a subway station in Philadelphia to see what the reaction would be, and of course, there was no reaction. Actually, nobody had any negative effects. It was an aerosol, and evidently no one contracted enough LSD to make a difference. Full information to be fully ethically acceptable. Consent must be both voluntary and informed. But fully informed consent is impossible, so federal guidelines have adopted the strategy of reasonably informed consent. A fair explanation of the procedures to be followed and their purposes, a description of the attendant discomforts and risks reasonably to be expected, description of the benefits reasonably to be expected, disclosure of appropriate alternative procedures that might be advantageous to the participant, offer to answer any inquiries concerning the procedure, instruction that the person is free to withdraw consent and to discontinue participation in the project at any time without prejudicing the status of the participant. And of course, this is something that happens with students. If they're given college credit, they have the informed consent. Because of informed consent, they can withdraw at any time, and of course, it won't prejudice the status of the participant. In other words, if they were offered credit for participating in the research, as long as they start the research, they still have to be given credit, so they can pull out at any time. That's the way it's supposed to be. I don't know how ethical some of my colleagues are, but that's the way it's supposed to be. Comprehension refers to confidence that the participant has provided knowing consent when the research procedure is associated with complex or subtle risks. How to ensure complete comprehension? The best way to do that is to use a highly educated participants, provide a consultant to discuss the study with the participants, and provide a time lag between the request for participation and the actual study. Sometimes it takes people time to make decisions like that. But the best way to do it is to use a highly educated participants. Of course, the problem, where are you going to find a group of highly educated participants? A college classroom is about the best place you can do that. Informed consent is not always a necessity. Informed consent is not a universal requirement for all social science research. Although desirable, informed consent is not an absolute necessity in studies where no danger or risk is involved. And of course, that is the problem, is determining whether there is a risk involved. Invasion of privacy is a big concern, especially in the era of the cloud. The issue, I hear every day that somebody stole somebody's nude pictures off the cloud, as weird as that is. The question has to be, why in the world would you put your nude pictures on the cloud where they could possibly be hacked? And of course, you've got hackers that are wandering around looking for all kinds of crazy things on celebrities and whatnot. Why in the world would you put your pictures up there? And the answer seems to be that people don't realize that's where, they take a picture with their telephone, they send it to somebody, they don't put it on the cloud, but it goes to the cloud anyway because everything from your cell phone goes to the cloud, and evidently that is the mistake that is being made. This issue is becoming more sensitive, privacy issues. Protection of privacy is becoming increasingly problematic because seemingly they can hack just about anything at this point. 3 different dimensions of privacy have been identified: sensitivity to information, setting in which observations are made, and dissemination of the information. Sensitivity of information refers to how personal or potentially threatening the information is that the researcher wishes to collect. The APA has said, that's the American Psychological Association. I am a member of the American Psychological Association. Religious preference, sexual practices, income, racial prejudices, and other personal attributes such as intelligence, honesty, and courage are more sensitive items than name, rank, and serial number, and that is what the APA has said. So all this information about who you are is really quite important. What companies are doing now, they're getting this information, and they're getting religious preferences, sexual practices, incomes, racial prejudices, and they are using that to target used specifically. So if you go on Amazon, Amazon knows exactly what you looked at before. They know what you looked at, not what you were and what you ordered, of course. But they also know what you looked at. So the next time you go on Amazon, they throw all this stuff at you that you have been that they that looks like your interest. And by doing that, they can get you to order something when you weren't planning on ordering anything. The setting of a research project may vary from very private to completely public. A particular setting being public or private may not be self-evident and may lead to ethical concerns. And that really is a problem. If you did research at Dene College, would that be private or public? Well, is it public? Well, yeah, it's public to some extent, but it's a private institution. So you'd have to get approval from, well, you'd have to get approval from the tribe, then you'd have to get approval from the school. So these have to do with where you can, where you can't do research. Dissemination of information concerns the ability to match personal information with the identity of the research participants. Fictionalizing the names of participants does not always protect privacy if other details are available. And that's the Masked Singer, I guess is what this is. This is from the Masked Singer. You can cover the person up, but you can't hide their voice, I guess. Anonymity is provided by separating the identity of the individuals from the information they give. Anonymity can be accomplished by not asking for participants' names. Researchers can also safeguard their data by introducing passwords and monitoring their information to improve privacy. I did research, and I had my participants' names. They filled out a form saying that it was a privacy form, and they filled those out. But what I did, instead of using their names, I used numbers. So I assigned each individual to a number. And I didn't really deal with their names again. I just had their forms on my paper, so that if somebody came and asked me, well, I couldn't give them that kind of information. But if somebody came and asked me, all these people participated in your research, did you get informed consent? Then I could show them that I did get informed consent, and there were the same number of participants as there were in the research. So I had all that information available to them, but I wasn't disclosing information. And of course, that would be fairly unethical for them to do that, for them to ask me about who participated in my research. But I could show them that they had signed informed consent forms. Confidentiality is the ideal, but not always easy to do. In order to permit outsiders access to data without compromising confidentiality, researchers have developed these techniques. Deletion of identifiers, such as name, social security number, and addresses. Crude report categories, release county instead of neighborhood, year of birth, but no other date, profession, but no specializations. Microaggregation, constructing average persons from data rather than specific data. Error inoculation, introducing errors into the identifying data while leaving the aggregate data unchanged. Regulatory mechanisms include legal statutes, institutional review boards, IRBs, at research universities and institutions, professional codes of ethics. Personal ethics of the individual researcher are and all of these, of course, are important. IRBs serve two major functions. They ensure the subjects are not placed at undue risk. They ensure subjects are not coerced and elect to participate in research studies by giving their informed consent, and that's what the IRB is supposed to do. There are various codes of ethics in the social sciences. Ethical codes are written to cover specific issues scientists encounter during the research within a particular field. Codes explain what is required and what is forbidden, as well as sensitize researchers to their obligations and best ethical practices. And that is the end of chapter 4. So what we're going to do is start chapter 5. I think, if I can figure out how to do this. There we go. Okay. So let's start chapter 5. Let's start at the beginning instead of the end. We won't go backwards today. Okay. So chapter 5 deals with research designs, different types of experiments. So now that we are ethical individuals and we would never do anything to harm anybody, especially our participants, now we're ready to put together our research design. The research design is the blueprint of a study. Classic experimental design consists of two groups, an experimental group and a control group. Now, probably if you're doing social science research, you're not going to use a control group. Um, this has to do with a classical experimental design. Social science does normally use classical experimental designs. In some cases, of course, they can, but in most cases, you don't do a control group and an experimental group. Both groups are equivalent, except that experimental groups are exposed to the independent variable and the controlled group is not. Assignment to each group is by chance. That is in a normal research situation. The Pygmalion effect. Rosenthal and Jacobson created an experiment with elementary students to see if they could create a self-fulfilling prophecy of success through expectation. They created a pseudo IQ test and gave it to a group of elementary students and then randomly selected the students who were bloomers and those that were not. The experimental group were the 20% of students selected as bloomers with all the other students as the control. The teachers were informed of the bloomers' potential. At the end of the year, all the students were retested. The intellectual ability of the students was the dependent variable. The 20% of students randomly selected as bloomers showed marked increase in IQ, despite the fact that that it was totally random. They may have been smart, they may not have been smart, but because they figured that the reason that they were their IQ had increased was because of the expectations of the teachers, the favorable treatment of the teachers, treating children like they were smarter than everybody else. Now, this is really kind of telling. This is not the first time we've seen this Pygmalion effect. All you need to do is pay attention to people, and they will respond in a positive manner. A number of years ago, they did a study at a telephone manufacturing plant, and at Hawthorne, Illinois. And what they discovered, if they pay attention to people, then they will exceed. They will exceed your expectations. If you don't pay attention to them, they will not exceed your expectations. So they were able to, just by changing things from time to time, they were able to get these individuals to produce more telephones. And this is known as the Hawthorne effect. Well, this is the same thing as the Pygmalion effect. All you need to do is treat people differently, and they will act. They will improve their participation in one way or another. The classic research design consists of two comparable groups, an experimental group and a control group. Randomization ensures the comparability of these groups. The researchers take measurements of the dependent variable, IQ in the Pygmalion experiment, twice, once before the independent variable is introduced to the experimental group, known as the pretest, and once after the experimental group is exposed to the independent variable, known as the post-test. And as we saw in the Jacobson, what's the other guy's name? Rosenthal and Jacobson's research, as we saw in their research, what they did, they tested them initially with a fake IQ test. They identified a random group of 20% of the students as exceedingly bright, and then they tested them after. They had a post-test after a select amount of time, and what they discovered was just because they had selected these individuals, they were considered, or their IQ improved because of the treatment of the teachers. It was the only variable that they didn't control. The classical experimental design is useful in social sciences because it helps us understand the logic of all research designs. It allows for causal inferences because we can observe whether or not the independent variable caused changes in the dependent variable. Social scientists use the experiment less widely than natural scientists, primarily because its rigid structure often cannot be adapted to social sciences research. And that's what I was saying before. This isn't all that common that we use a classical experimental design. Thus, social scientists frequently use designs that are weaker for drawing causal inferences, but are more appropriate to the type of problems that they examine. What do you want to examine? We can examine the impact of learning the Dene language. How in the world do we do that? Well, we certainly wouldn't be able to use a control group and an experimental group. That just doesn't fit. The demonstration of causality involves three distinct operations: covariation, non-spuriousness, and time order. And this, of course, is kind of funny. It's a rather interesting phenomenon. Every time I press this lever, that postgraduate student breathes a sigh of relief. Anyway, that's experiments. It's an experimental joke. Got another one coming up. Covariation means that two or more phenomena are vary together. In research, the notion of covariation is expressed through measures of relations commonly referred to as correlations or associations. In order to infer that one phenomena causes another, a researcher must find evidence of a correlation between the phenomena. And of course, on the left it says, we found correlation in the data. Everyone take a razor. Shaved heads cause the sales to go up. And so they're going to have everybody shave their heads, as fun as that is. The researcher must demonstrate that a covariation is non-spurious. A non-spurious relation is a relation between two variables that cannot be explained by a third variable. Researchers have established that a relation is non-spurious, have strong evidence that there is an inherent causal link between variables, and that the observed covariation is not based on an accidental connection with some associated phenomenon, such as this one. The shaved heads increase, it goes up as the sales goes up, so everybody's going to shave their head. The joke to the right, do you think all these film crews brought on global warming, or did global warming bring on all these film crews? And of course, that is, there was those two variables really have nothing to do with each other. One last operation that must occur in causation inference is time order. The researcher must demonstrate that the assumed cause occurred first, or the change happened prior to the assumed effect. This is not always easy. Which came first, the chicken or the egg? Does the success of the student precede increased educational expectations of parents, or does increased educational expectations precede success of the student? Does depression precede substance abuse, or does substance abuse precede depression? Does achievement follow motivation, or does a change in the level of motivation follow achievement? Classic research design consists of four components: comparison, manipulation, control, and generalization. The first three are necessary to establish that the independent and dependent variables are causally related. Comparison allows us to demonstrate covariation. Manipulation helps establish the time order of events. Control enables us to determine that the observed covariation is non-spurious. Generalization, the fourth component, is the extent to which the findings can be applied to larger populations and different settings. Hypothesis: excessive television viewing by male adolescents leads to sexist views. Comparison: we can compare the views of teen males who watch excess TV with those who watch minimal TV. Manipulation: we can have one group of moderate TV watchers binge watch a sexual themed show and then measure their sexist ideas. And of course, that is one way of doing it. You can see the comparison, the manipulation, the control, And of course, the generalization comes after the manipulation. Control requires that the researchers rule out other factors as rival explanations of the observed association between the variables under investigation. They must establish internal validity. Possible intervening variables and extrinsic factors for the TV research, religious affiliation, political affiliation, parental beliefs, peer beliefs, strict educational teaching, region of the country. And all of these could affect whether an individual has sexist ideas um, from from a piece of information. Problem of internal validity: the requirement that the researcher rule out other factors as rival explanations of the observed association between the variables under investigation, extrinsic and intrinsic factors. To establish internal validity, one must answer the question of whether changes in the independent variable cause the dependent variable to change. The effort to attain internal validity is the guiding force behind the design and implementation of a research project. Um, so when I was doing my research, I was looking at resilience, and I was trying to determine what causes what causes resilience, what allows people to be resilient. And I was looking at a native group. I've told you about my research before, and we were looking at various factors. Does age have something to do with resilience? Does the older you are you more resilient, or the younger you are you more resilient? Research tells us that the younger you are, the less resilient you are. As you get older, you become more and more resilient. Research also tells us that females are more resilient than males. Is that a factor? Um, Research also tells us that the more educated you are, the more resilient you are. Is that a factor as well? Trauma, the level of trauma. The more trauma that you've experienced in your life, the less resilient you're likely to be. And the last had to do with culture. The stronger your culture, the more resilient you were. And of course, I looked at all five of those factors on on an Indian reservation in Montana, and what I discovered was that there was only one factor that caused increased resilience, and that was cultural factors. The rest of it was insignificant. Extrinsic factors, biases called selection effects, can be introduced into research because of extrinsic factors that differentiate study participants. Selection effects are especially problematic in cases in which the individuals themselves decide whether to participate in an experiment. They did an experiment a number of years ago with National Geographic. It had to do with odors. Now, the interesting thing was it wasn't really a very scientific research, even though there were tens of thousands of people that did it. Those individuals, there was that selection factor. The individuals that were interested in smells were the ones that participated. The ones that weren't interested in smells, well, maybe they would have skewed the results, or maybe they would have changed the results. So there was a selection bias involved. And there was another one that the Psychology Today did that dealt with humor. Well, some people find humor interesting and other people find it not interesting at all. So could it have skewed the results? This strange selection bias. The only people that did it were the people that were really interested in humor. Maybe they thought that maybe they found jokes pleasant or something. And other individuals, the ones that thought jokes were stupid or silly, they didn't participate at all. So that was a selection bias. In such cases, the investigator cannot tell whether the independent variable itself caused the observed differences between the experimental and control groups, or whether other factors related to the selection procedures were responsible for the observed effects. Intrinsic factors include changes in the individuals or the units that occur during the study period, changes in the measuring instrument, reactive effect of the observation itself. The major intrinsic factors that might invalidate a causal interpretation: history, maturation, experimental mortality, instrumentation, and regression artifact. Many of the intrinsic factors can interact with the extrinsic factors. Selection history interaction poses a threat when the experimental group and the control group are selected from different settings so that each setting might affect their response to the treatment. Selection maturation interaction occurs when the experimental group and the control group mature at different rates, such as females mature faster than males do. So if we were doing an experiment looking at junior high students, uh, late elementary school and early junior high students, we might find some different results due to the females in the group maturing faster than the males. If we were looking at dating, for example, and we were looking at junior high girls, why do junior high girls start dating before junior high boys? Well, junior high girls mature faster, so they are physically older than males. Most males are. Two methods of control to counteract the effect of extrinsic factors: matching, controls for variables that are known to the investigator prior to the research operation. We can match in lots of different ways: precision matching or frequency distribution matching. How often do you watch television? We will match somebody. This person watches for 4 hours a night, and this person watches for 4 hours a night. One would become the control, the other would become the one would become the control, the other would become the experimental individual. Randomization helps to offset the effect of unforeseen factors, and of course we look at different ways of precision matching. And once again, randomization is a process thereby participants are assigned to the experimental and control groups. Randomization cancels out the effect of any systematic error due to extrinsic variables that may be associated with either the dependent variable, productivity, or the independent variable, participation in decision making. Randomization controls for numerous factors simultaneously, even when the researcher is unaware of what they are. Control groups used to mitigate intrinsic factors. Control group does not receive the experimental stimulus, of course. The control and experimental groups should be selected by matching or random selection so that they have similar characteristics. Both groups should also experience identical conditions during the study except for their differential exposure to the independent variable. When I was working in Vienna, Virginia, I was working at a pediatrics clinic, and we were doing experiments with otitis media. And what my doctor was doing, he was treating them with either a new drug, a new antibiotic, or it was a broad spectrum antibiotic, or he was treating them with the old drug, and he didn't know whether he was using the new drug or the old drug. And what he was trying to do was to determine how long it took these individuals to recover from their otitis media, from their inner ear infection. Not inner ear infection, middle ear infection. Anyway, so that's what we did. And he would call them up on the phone, say, how is the individual? Are their symptoms going away? And he would determine how fast the antibiotics were working, the old antibiotic or the new antibiotic. And by doing this, he was able to, or the drug company was able to say, look, if you treat with our broad spectrum antibiotic, it works in 93% of the cases, and it works twice as fast. That was the idea. And we didn't know. We had no idea whether the child was taking the new drug or the old drug. Generalizability, external validity is the extent to which research finding can be generalized to natural setting and larger populations. Since it was all randomized, since the otitis media research was completely randomized, we had no idea whether we were treating. Of course, this is a very diverse population in Washington, D.C., right outside of Washington, D.C. So we were treating African Americans. We were treating certainly the white population. We had Asians that came in, and didn't have any natives. Of course, that's Washington D.C. for you. But it was really kind of interesting research. And actually, we never discovered how our results turned out. All we knew was that this individual recovered faster. Now, potentially, they may have had a stronger immune system, and that's what created the situation. That's why they recovered faster on the new drug than on, if they had taken the old drug, they may have recovered just as fast. But of course, we weren't the ones making that determination. It was the drug companies. The two main issues of external validity, representativeness of the sample, and reactive arrangements in the research procedure. We were talking about children. We were talking about otitis media. We were talking about a relatively rarefied population. This was a very wealthy section. Vienna, Virginia is one of the wealthiest areas in the United States, literally. So all these individuals were fairly healthy before they came in. Really kind of an interesting group. Four major design types: classical experimental that we've already talked about, the quasi-experimental design, the cross-sectional design, and the pre-experimental design. The classical experimental design allows for pre-test, post-test, and control group experimental group comparisons. It permits the manipulation of the independent variable and thus the determination of the time sequence. Most significantly, by including randomized groups, it controls for most sources of internal validity. However, this design is generally weak on external validity and does not allow for generalizations to be made to non-tested populations. The pretest provides an assessment of the time sequence and the basis of comparison. The problem with the pretest is that it sensitizes the sample population to the measure and may seriously affect the post-test, and thus the generalizability of the research. Pretest, post-test, that's, if you remember the Pygmalion research, they pre-tested the students to determine their IQs, and then they post-tested them to see if the bloomers were the one had higher IQs than they did before, and that's what they discovered. So that's interesting as that is. The Solomon 4 group design contains the same features as a classic design, but adds an additional set of control and experimental groups that are not pre-tested. Therefore, the reactive effect of testing can be measured directly by comparing the two experimental groups and the two control groups. Post-test only control group design is a variation of both the classic design and the Solomon design. Post-test only control group design omits pre-tested groups altogether. The post-test only control group design groups are identical to the last two groups of the Solomon 4 group design, which are not pre-tested. Individuals are randomly assigned to either the experimental or the control group and are measured during or after the introduction of the independent variable. Post-test only control group design controls for all intrinsic sources of invalidity. Factorial design examines the effect of more than one independent variable simultaneously. If each independent variable has only two possible values, dichotomous variables, in other words, it's either a yes or a no, male or female, like in my research, traumatized or not traumatized. Actually, I had levels of being traumatized, male, female, educated or not educated. Four experimental groups will be needed to study all combinations of these two variables, as you can see from the factorial design example. Factorial design, looking at company size and decentralization against morale. Size and decentralization are independent variables, and morale is the dependent variable. The four possible combinations are large size and high decentralization, small size and high decentralization, large size and low decentralization, small size and low decentralization. And it doesn't have the results. Well, I guess it wouldn't have the results. Factorial designs, chief advantage of factorial design is that they may considerably broaden the range of generalizability. The researchers is able to infer that the effect occurs similarly across several levels of the variables, or that the effect is different at different levels of one or another of these variables. Another advantage is that it allows assessment of how two or more independent variables interact. And that is the end of chapter 5. Now we're going to start with chapter 6, looking at other research designs, the cross-sectional and the quasi-experimental designs. Simultaneous stimulus-response relationships are well suited for the experimental investigation. Stimulus-response relationships are characterized by an independent variable that can be manipulated by the researcher, and of course that's what was going on with the television research. It was a stimulus response. Does watching television shows about sex make adolescent males more sexist? Stimulus response relationships are characterized by an independent variable that can be manipulated by the researcher. The researcher might induce stress or expose research participants to a political candidate's advertising campaign. The dependent variable would then be a direct response to the independent variable. It could be a psychological reaction to stress or a strong emotion or opinion about the political advertising campaign. Property disposition relationship is the relationship between some characteristic or quality of a person, their property, and a corresponding attitude or inclination, their disposition. An example would be socioeconomic status and political tolerance. Another example would be the relation between race and prejudice. And of course, we've talked about this in social psychology. The lower the socioeconomic status, the more rigid the individual seems to have their political ideals. The higher the socioeconomic status, the more flexible their political ideals. So if we look at people in the United States who voted for Donald Trump, a lot of people that voted for Donald Trump were working class individuals, more rigid in their ideas. And the people that voted for Hillary Clinton were more middle class, and they were the ones. Males, of course, are more rigid than females, and females voted for Hillary Clinton at a higher level, and males voted for Donald Trump. Looking at the next election, of course, looks like it's going to be Joe Biden and Donald Trump. That's exactly what we're finding again, that females are going to be voting for the more liberal individual, Joe Biden, and working class individuals and males are going to be voting more. They're more likely to vote for Donald Trump, but we'll see what happens. Okay. Stimulus response relationships differ from property disposition relationships in 4 ways. The time interval in a stimulus response relationship, the interval between the introduction of the independent variable and the response to it is relatively short. In a property disposition relationship, the time interval can extend over a long period of time. In other words, property disposition, this is somebody that has been trying to determine how they feel over a long period of time. Whereas stimulus response, there's something happens like the George Floyd murder by the police. That's the stimulus was the murder, and the response is the Black Lives Movement, joining a Black Lives Movement demonstration someplace. Property disposition relationship would have to do with how you feel about race, how you feel about different races. This is something that you have acquired over an extended length of time. Degree of specificity, a stimulus is usually easy to isolate and identify, and its effect can be delineated concretely. And just like the George Floyd situation, that happened about a month ago, maybe 6 weeks ago, and we've had demonstrations around the United States ever since. A property such as a social class is more general and incorporates various factors, prestige, occupation, education, and all exert their relative influence. The nature of comparison groups. When studying a stimulus-response relationship, a researcher can compare two similar groups, one that has been exposed to the stimulus and one that is not, or the same group both before and after exposure to the stimulus. When studying a property disposition relationship, a before-after comparison is impossible, especially with properties do not change, such as gender and race. And of course, there's no way we can, well, I guess we can change our gender, but we certainly can't change our race. We can change our identity of how we identify our own race, I guess. But we certainly, yeah. Well, anyway, the time sequence of events with stimulus response relationships, the direction of causation is relatively clear, especially when the research design allows the researcher to make before-after comparisons. When properties are permanent, such as race and gender, researchers establish causal direction based on the fact that these can only be determining factors, not determined effects. Because of the difficulties with property disposition relationships, social scientists cannot apply comparison, manipulation, and control in the pure experimental sense. Yet social scientists try to approximate the experimental model by employing specialized data analysis techniques that compensate for the limitations inherent in studying property disposition relations. A cross-sectional design looks at different groups at the same time to determine if there is a difference in their responses. The groups can be age groups, elementary students at the same time as middle school students and high school students, economic groups, poor people and wealthy people, racial groups, whites, blacks, Hispanics, natives, and Asians. And we can do a cross-section of a lot of different, we can cross-section society at a lot of different levels. Cross-sectional design are one of the most widely used designs in the social sciences and are frequently employed in survey research. In most cases, researchers in cross-sectional studies are simply trying to describe relationships between variables. Hence, cross-sectional studies are usually referred to as correlational studies. We are correlating one age group with another, one race with another. We're trying to look at people from a broad spectrum of individuals with different attitudes. Exit polling done during the 2012 presidential race between Barack Obama and Mitt Romney looked at the impact of race ethnicity on the candidate of choice. Race ethnicity is not a variable that can be manipulated, nor does it lend itself to before and after comparisons. And of course, if we look at who voted for who, as we can see, Hispanics voted for President Obama at a much higher rate, 71% to 27%. Whites didn't vote for Barack Obama at the same rate as they voted for Romney, 59% to 39%. Blacks, of course, voted overwhelmingly for Barack Obama, 93% to 6%, and Asians also voted for Barack Obama at a rate of 73% to 26%, very similar to Hispanics. Quasi-experiment, and of course, Barack Obama won by quite a bit, so he didn't really run away with, well, I guess you could say he ran away with the election. Quasi-experimental designs allow researchers to select random samples from the population, but do not require the random assignment of individual cases to the comparison groups. Quasi-experimental designs are weaker on internal validity than experimental designs, so researchers must depend on data analysis techniques for accuracy. Quasi-experimental designs are superior to cross-sectional designs because they usually involve the study of more than one sample, often over an extended period of time. The least elaborate design for contrasted group design is one in which the individuals or other units of analysis are regarded as members of categoric groups. Members share one or more attributes that assign them to an identifiable category. In the non-equivalent control group design, researchers compare two or more intact groups before and after the introduction of the treatment variable. Non-equivalent control group design is a more elaborate design for contrasted groups. A college looking at remedial English classes compared fall with spring semester remedial classes. The dependent variable was the success the students had in the freshman English class after taking the remedial classes. The results showed that the students who took the remedial English classes did better in the freshman English classes than the students who did not take the remedial classes. Planned variation designs exposed individuals to stimuli that had been systematically varied in order to assess their causal effects. The Head Start planned variation is an example of this design. Overall, both the sponsors programs and the regular Head Start programs tended to accelerate certain kinds of academic performance. Pooling the 11 specific sponsored sets of classrooms and comparing them with the regular non-sponsored Head Start classrooms showed no large differences. When the sponsored set of classrooms were compared among themselves, some differences in performance emerged on several of the cognitive tests the children were given. Panels are a design in which the same sample is examined at 2 or more time intervals. Panels allow researchers to approximate and therefore, after a condition of experimental designs more closely by before after condition. Okay, wait a minute. Let me do that again. Panels allow researchers to approximate the before after condition of experimental designs more closely by studying a group at 2 or more points in time. The main advantage to a panel is that it enables researchers to determine the direction of causation. Problems with panels: obtaining an initial representative sample of respondents who are willing to be interviewed at set intervals over an extended period, as well as maintaining these participants throughout the study. Repeatedly interviewing the same group many sensitize the respondents to give a given set of answers. This is called panel conditioning. Time series designs are used in cases where no comparison or control group is available for assessing cause and effect relations. Time series designs are studies in which pretest and post-test measures are available on a number of occasions before and after the activation of an independent variable, where an investigator attempts to obtain at least 3 sets of measures before and 3 sets after the introduction of the independent variable. Extended time series design controls for maturation, where there is data gathered over a number of years prior to the measured changes. A classic extended time series design was a study of traffic deaths in Connecticut in the 1950s. Traffic deaths were always studied, and the demographers discovered a peak in 1955, but the number of deaths, though they fluctuated, were always high. In 1955, there was a crackdown on speeders, and 1956 showed a sharp decline. However, researchers discovered that traffic deaths fluctuated wildly, and statistically, it could not be shown that the crackdown caused the precipitous decline in 1956. The steady decline after 1956, however, demonstrated that the crackdown's effectiveness. And this is what it looks like. As you can see, the traffic deaths really spiked in 1955, started coming down in 1956, and it really declined in 1959. So they thought that they had done something. So what did they use as their control? Really kind of curious. Control series designs attempt to control aspects of history maturation and test-retest effects by comparing the result to a non-comparison group. In Connecticut traffic death study, researchers compared Connecticut's death rate to that of neighboring states and discovered a steady decline after the crackdown that wasn't evident in neighboring states who had no crackdown. And as you can see, Connecticut did have a decline, whereas other states stayed about the same. In the initial design in the Salk field studies, the idea was to give the vaccine. We're talking about polio vaccine. Jonas Salk was the one that came up with the polio vaccine. In the initial design in the Salk field studies, the idea was to give the vaccine only to second graders whose parents volunteered them for the study, and not to give it to first and third graders who comprised the comparison groups. Some state Public health officials recommended a control field experiment that randomized the distribution of vaccine among volunteers from all grade groups. In the end, some states applied original design and some applied randomized control design. The polio was hit at the end of World War II. It scared people. It was like the coronavirus. It just really scared people. And it hit kids. It didn't really affect adults so much, but this is the children that were growing up at the time. They were the ones being affected. And it scared people a lot because it caused all kinds of problems. One, it caused the individual to one leg to not develop like the other leg, so it made them more likely to look like they were crippled. Um, it also affected their lungs and with select individuals. And some of these people had to be put on respirators for the rest of their lives. And of course, they didn't live very long. But this was our children, and it scared people a great deal until they found a vaccine. As you can see, this is 1954. This is a picture from when this happened. So I started school in 1955, and I did get the polio vaccine. There was an individual in my elementary that graduated with us who had contracted polio before she started school. Really scary. I mean, nobody knew where the polio virus came from, and or how to control it. It was kind of like the coronavirus. Well, what do you do? What do you do? Well, one of the ways that it was being controlled was by sheltering in place, just like what we're doing with the coronavirus. But the difference was, whereas the coronavirus seems to kill off, seems to more destructive for individuals who are older or have some kind of physical infirmity, such as diabetes or cancer. Polio struck children, healthy children, and it was just a tragedy that no one could control. As sad as that is. My first mother-in-law had polio in her feet, as weird as that sounds. So her toes were all curled up. It was really kind of curious. They did all kinds of surgery trying to straighten her toes out, trying to straighten the bones in her feet out, but she hobbled around most of her life. Pre-experimental designs may be the only available technique for many policy questions when it is difficult to implement an experimental or quasi-experimental design. Pre-experimental designs have no control group. One example of a pre-experimental design is the one-shot case study, which involves an observation of a single group or event at a single point in time, usually at a time of change. One-shot case study limitations include no control over extrinsic and intrinsic factors. It does not allow for before, after, or control group experimental group comparisons. They cannot be used for testing causal relations. Pre-experiments are the weakest research designs because most of the sources of internal and external validity are not controlled for. The risk of error in drawing causal inferences from pre-experimental designs is extremely high. They are usually primarily as a basis for pretesting some research hypotheses and for exploratory research. And that looks at all of the different designs. And that is it. We are done. Let me see if I can do this. What am I doing? Okay, there we go. Okay, need to stop.